Oh yeah, I'm live. Forgot about that. I'm gonna get some tea. I'll be right back. There we go. So, last time we left off, we got some population stuff going. Not really doing anything that interesting. So we need to, in the same way that we're killing generations, we need to birth generations. Handle death. Public avoid. Handle birth. Below current year. I don't know if it needs that. Now the thing is, I guess in reality, birth might not really be something that I need to handle inside of the generation. Right? Because death is handled every year. So, how do we generate a new generation? The reality with that is that it really comes down to the generations themselves. So in order to generate a new generation, I kind of need to go through all the generations and run tests. Now, I kind of think that shouldn't really be in generation. I think that should be in population. So we've got handle deaths. So what about public void spawn new generation? Maybe. And I guess current year wouldn't hurt to take in. I think it should be an integer. Probably. Here, current year needs to be a float because we're... Well, actually, not really. Current year could be an integer. But what I don't like about this is that it basically means running through every single generation and running a random roll. Which is kind of bad in multiple ways. Like I don't like it from a performance point of view, and I don't like it from a functional point of view. But we're gonna do it anyway. So for generation list.count, we're gonna say we do need to go into generation though, and we're gonna actually have a public int called handle birth. And actually, yeah, we're gonna do handle birth. And we're gonna say int births equals 0. Return births. And then we're gonna say so here, right? We have if we take the current year here too, we then need to check. Honestly, the same as here. Right? Pretty much. Except all right. Dinosaur. How did we do it in Dinosaur? He just has a bunch of constants here. But I don't want to have the constant in game one. I don't actually know. C# difference between const and static. A static read-only variable can be written to by a static constructor. That is an important difference between a const variable and a static. A variable declared as const must be assigned a value at declaration, and this value may not then change at a later time. The value in a const variable is what's called a compile time value and is immutable. Only primitive or built-in C# types are allowed to be declared const. You want to use const when you have a variable whose value will not change ever, during the time your application is being used. Any variable declared as const will also implicitly be declared static. Oh, okay. What does static do? A static member belongs to the type of an object rather than to an instance of that type. Yeah. It's very similar, but it's not the same. Read only. All right. All right, we got some tea. I always have a headache at this time of the day. It's great. All right, so let's add a const. So wait a second. Oh, it closed the entire other solution. All right. So in system, let's add class. Let's call this one const bars. Should this be see? Should it be in the, like, how can you just type things in a namespace? No. So it needs to be in a class, and then that means this class should be static, right? Because we don't want an instance of this, we just want it to contain our consts. It should never have to be instantiated. So here we then have system.constVars, and then here we now have the unfortunate reality that I have to write something like this, which is minimum earthing age. So and now it's like, what should this be set to? I don't actually agree with it being 18. Oh, hey, I've got the starting soon now. There we go. There's my PNG. Like 18 is the PC choice, right? Handle births. So what we need here is this is gonna be birth rate. And it's gonna be, so 1 minus current age divided by life expectancy. But current age should be now this is a little bit different, right? So this should not be 1 minus. This should just be like this. Well, maybe 1 minus still makes more sense. So current age divided by life expectancy. The thing is that if I go with current age only, then we're gonna start at like 18 or whatever I set it to. And it's going to be lower than it should be, because we want to start at like 100% basically. So we're gonna do current age minus system dot const dot minimum birthing age. Oh, Albine, how's it going? However, no, it's a minus, so that's fine. And then divided by life expectancy, right? So what we're gonna get there is value that is higher. I'm horrible? I heard you weren't doing so well. But I didn't hear anything else. What's going on, big guy? So we need births. The births are gonna be birth rate times people count cannot implicitly convert float to int. Yeah, that's fine. No, it's gonna be an int. There. My doctor refuses take the 1 minute it would take to read my question and answer it. Instead, he just answers, take this med, but it doesn't say for how long. Or should take the other med. Alright. That sounds like a classic doctor. Dude, they didn't tell me anything when I had my operation, like literally nothing. It was just like, you're gonna go home, take these antibiotics, and you know, bye-bye. They didn't really give me like any information, like what can I do? How long is it gonna take to heal? Like, not much. So this is gonna be, okay, so yeah. So here now we're gonna birth an amount of people equal to a percentage based on the current age divided by life expectancy and the people count of that generation. So to spawn a new generation, we're gonna say int total births equals 0. Then total births plus equals generation list I dot spawn dot handle birth current year. And then we're getting births there. And then we're gonna say generation list dot add new generation this dot or this comma current year is the birth year and the people count is total births. And then current year, handle deaths, current year. So we're gonna change this. So in population, instead of handle deaths, we're gonna say public handle year. Now the thing about this is it's a little bit weird. So Unity 2D is retarded since the camera jitters like crazy, causes massive blurs on 2D games when you move. It's not necessarily Unity's fault. It's just the reality that programming a camera for 2D has specific rules. You need to do things in certain ways, otherwise it doesn't work. So there's not actually anything wrong with like getting it to work in Unity. It's just you gotta do it you gotta do it right. But you can't just use the default stuff. And that's what I always say about Unity. Whatever default functions you find in there, you just can't rely on it. It's just gonna be dog shit. So we're just gonna do handle deaths, current year, handle births. Oh, spawn new generation, current year. How's the simulation going? It's going forward. I mean, it's still nothing. But we'll see how this ends up working. I'm gonna run it in a sec here. So here now, instead of handle deaths, this should be... Right, because this is in the main controller. Public void handle year. Current year. If population does not equal null, population dot handle year, current year. That shouldn't really exist. And this should be handle year. Our population count is absolutely skyrocketing. Which is probably not quite correct. So let's see. When we do spawn generation here in population, we need to say I if generation list dot I dot birth year is less than less than current year minus system dot const vars dot, oh, we don't need that, we can just do const vars apparently. Const vars dot minimum birthing age. So if the birth year is the 5 years ago, and let's say the year is year 100, and they were born in 95, that means that if current year, which is 100, minus minimum birthing age, which is 18 in this case at the moment, then we do something. Yeah. Then we handle birth. But this is going to come down to algorithm as well. What's going to happen to the population count here? Because it's weird that it starts to like spiral out of control, I feel like. And we're also just losing generations. So we might end up with like 30 generations here or something. It's kind of weird. Does it ever stabilize? Around 25 generations. Okay. Oh, 27, 28, 29, 30, 25, 25, 20. What is happening? Yeah, this is gonna be, it's gonna be a little bit complicated because the basic ass algorithm I have now, it doesn't really properly represent how anything would work. Because right now it's basically like when a generation reaches the age, and a generation is a year, like the people that were born in a certain year is one generation. And when they reach 18 years of age, 100% of them have children, right? And that's added to the generation in the back there. Or to the first generation, the youngest generation. Now the list is not in order in any way. I don't know if that matters, but it shouldn't. But there is also an issue of right now I'm handling death and birth in procedural order, which doesn't really make sense. They happen at the same time. But in reality, because it's static, they're just going to cancel each other out. Which they kind of should. Like, they should kind of cancel each other out. I think we're reaching a point where it's no longer just a fun basic thing, and now I have to actually figure out how to do this seriously. Because it needs to be... I don't know what it's called. I genuinely don't know how math works. Like, I don't know math names. But it needs to be an exponential curve. Where, like, birth rates are high in the beginning and they stay, like, somewhat high. Like, it shouldn't be linear. And then it should go down after a certain point. Um, I actually think birth rates should be a I don't know. I don't know how, man. I don't know. Let's just open this thing instead. Graphing. Help flashbang. How do you make an S curve? Map. How to make an S curve. One divided by 1 plus exp. Fuck is exp, bro? It's just an... One. One divided by parentheses 1 plus exp parentheses minus x. What the fuck is exp? Exponential math.exp. It's just to the power of. Fuck you. What the fuck is happening there? What is this function, dude? Here we've got a curvature. That's not what I want. Do I have to do some cosine shit here? Oh. I genuinely have no idea how cosine or sine works. What is this, bro? Lore. Trigonometry, sin, x. How does that even work? No, it can't be something like that. It needs to be like 2x plus 2x minus x2. No, it does need to be, the exponential does need to be negative. Now we're talking. If I do this, then by 2, it equals 2 again. All right, that's enough random math. It's literally like this. This is literally what I want my curve to look like. Except in reverse. They do seem to say... It does seem to... One divided by 1 plus... But that's not real. What? Stop. Oh my god, it's so bad. Plus minus x I don't understand. Plus the formula is retarded. Like, this isn't a real formula. Like, it isn't. Go fuck yourself. This doesn't work. This isn't real. There's nothing worse than Googling math, because everyone who writes math is a retard. They are completely unable to actually write anything that makes any sense. But I also think you can't... Like, you can't do this. I can't have X and K in here at the same time. And for some reason, editing like a single value is completely impossible. -2. How to make an S-curve. Maybe there's no actual good math to solve this. Maybe I need to hack it. This, the green one, is actually kind of close. I wish there was an actual calculator software that wasn't ass. I think Wolfram might have an app, but I'm not sure. I don't think Wolfram is really that good, it's just overcomplicated. What if I have now we get something like that. This is like infinity glitch, by the way. Why? Look at this. Like, it's so stupid. Look, what is it doing? Why does it do that? Like, why does it change the formula to that degree? Like, all it says here, and this is why it's so frustrating, is all it says here is 2 minus 2x. And all I want to do is make it 2.5x. And now it worked. I guess. So this is basically what I would like, right? Except I would like it flipped on the side. Which would, I mean... That's not, like, the whole story, though. As you hear, it goes up to 4. I think this has to be a 2-part equation. It's gonna have to be something like... Nah. Programming. Curves. Coding curves. Show me curves, brother. Show me the curves. What are we even looking at? That's fine. This isn't what I want. I think I have a website. Programming easing C# easing functions. Color interpolation. Ray tracing. I'm just checking my bookmarks. I don't really think I have anything here. Not really. C# easing functions. In, out, ease. This is what I want. I want a cubic in, out, ease. And that's not a mathematical formula as much as it is it's programming. If x is less than 0.5, then 4 times x times x times x. Oh, that's 4x. What do you call that? That's not squared. That's to the power of 3. But yeah. Something like that is what I want. Fertility should be the highest early on. And then as they reach middle age, it should go down to almost non-existent, but possible by the end, right? The out, like this is meant to be a certain amount of ease, right? So the out could probably be squeezed lower. I'm not sure what I would change here, though. Oh, Thomas. Nah. I've only been streaming for an hour. I wasn't streaming in the middle of the day. I was doing other things. I just want to do some programming here at the end of the day. So what we need is public int east birth rate. Ease in out. Let's just call it something like that. My job being a programmer? Yes, I am a programmer. I also do pixel art and other things. I do writing as well. So load, what should we say here? X. Call it X. What is wrong here then? Oh, right. No, it should return a float. Oh, because this is the ease, right? Double to... Where's the double, bro? Math F. Math F. .pow there. Alright. So now we have an ease here. And... What value are we actually gonna get here? So if let's say we've got 0. Huh. Bit more. Why does it not work? Hello. Calculator is bugged. Can't type. There. So if we have an x that's 0.2, then it's going to be 0.2. It's going to be 4 times 0.2 power of 3. This is going to be 0.008. Zero point zero 32. Because what's gonna happen is, like, we have birth rate here, right? But what we actually need to do is we need to do ease in out birth rate, I think. I don't know if this actually makes any sense. Hello Mark, how's it going? And even if I run it, it's not gonna, like... Why are they dying so hard, dude? I feel like they died, like, way harder now for whatever reason. But the reality is that doing this with just an algorithm like this is pretty much impossible, because the reality is that what I'm trying to do is I'm trying to simulate population, or, well, yeah, population. And the population should grow, generally speaking. But like if we say it's in a vacuum, there should be die-off, but the growth should exceed the die-off, right? That should be the baseline. Right now, I think it's the opposite. So we should tweak it until we have generations dying off. But the population should grow always, slowly. But the amount of generations should never exceed 80. I think that's a good first goal. And then the deciding factor after that is going to be first some random variance, but random variance doesn't really matter that much. It's just, you know, it's just a thing, right? It doesn't really matter. And then we need to add outside influence. What does that mean? It means food. It means housing. That kind of stuff. Resources. And that's going to affect the birth rates as well. So if a certain generation is born during a year where there's like poor conditions for whatever reason, even if it's just like rainy or something or whatever, I don't care, then that's going to be what affects the birth rate. Like there are going to be cofactors that affect the birth rate of each generation, and then that will affect other things. And that will more control like rises and like the rise and fall of any population. But within a vacuum, the population should grow. And the way it's working right now, when it comes to deaths, is kind of bad. So go back to graphing. Thank God. So what would that look like? Let's change this from, let's go with like -5 to 100, maybe. So I'm going to set this to 1000, make it a little bit more distinct. So let's say we start at 800, right? Then what we want is by 80, this should go to 0. If I do -x, it's just going to be that. So it's gonna have to be 10x for it to linearly reach minus 80. But what if it's 10x squared? Now they're dead almost immediately. I feel like the mortality is way too high here. See, the higher the power of is, the sharper the curve becomes. But you also have to do much smaller steps, right? So if we do something like this, then by the time they are 20 years old, in a population of 800, by the time they're 20, one person will have died. Gonna go draw? Alright, dude, good luck. Hope you get better, man. So I think a 5 might actually be too severe. And here, by the time they are 20, then 3 people have died. Maybe even 4. By the time they're 40, they've lost 50 people. By the time they're 60, they've lost 330 people. By the time they're 75, they've lost nearly 600. But the question is, what is the function of this? Or how do I write this in code? So because I need to get the value, right? Like if I want them to be dead by 80, there has to be a way to determine that. So what would that be, right? Like what is 1 divided by 80? $0.125. But how do I... And this isn't, it's not like this is the perfect value either. It's like, it's gonna be something like that, you know? Math is hard, man. Because the thing that is kind of hard here is like, how do I tell the algorithm, like, this curvature is right, but how do I tell the algorithm for the curve to reach 0 by the time we're at 80? Because 80 could be anything. This is just the life expectancy right now that I've hard set to 80. But that could be like 67 or whatever. Actually, I don't even know if I would necessarily have a life expectancy. Is that something I need to have? Kind of think probably, yeah. Probably, yeah. So how do we get that value? 80. One divided by 80. Not a triple root. Hmm. There are more issues too. Holy shit. I don't know if I can figure this out. But the reality is that I guess X is kind of just current year. But the value is still like, what? Where am I getting that from? Because that's not a magic value I can just always use, right? Also, what if this is like 600? because now it's not based on the original population. So the smaller the population is, the faster they're gonna die. So, ugh. I don't know if you can use Y. No, you can't do that. Oh, you can do equalities here. I don't know if this is something that will make sense to graph out. Oh. Oh, so cool. I'm basically trying to kill off a population, I guess. So let's say a generation is born on year 1. And that generation is born with 1,000 people. And it has a life expectancy of 80. And in this case, 80 basically means that the generation is dead at 80. Like 0 people remain at 80. And I'm just trying to figure out how I should handle that mathematically, because each year I'm going to kill off a certain percentage of the people based on their age. So when they're 20, maybe like, 0.01% will die or something like that. And then it's going to keep going down until they're gone. But my brain is just cooked. So it's like, if you just have a function of like 8,000, let's say they start at 8,000, and you just keep the 8,000 value, then you can just go like, how do you do it? You basically do like current age divided by life expectancy, right? And then you get a percentage, and then you can say starting population times 1 minus current age divided by life expectancy, and then you can say current population equals, you can do something like that, right? And that way you can guarantee that when current age reaches life expectancy, then this becomes 1. 1 minus 1 is 0. Starting population is 0, right? You can do that. But I don't know if I want to do it like that. I mean, technically I could do that, but I think that's not right. I think I'm approaching it wrong entirely. Because I'm trying to kill them off by the time they're 80, but that's not necessarily like how things have to be. I think it would be fine if it's like by the time they're 80, there might still be people alive, so that it overshoots 80. But it's also okay that that they're all dead, because each year I want to kill off a certain percentage of the population. And if you do that, it kind of messes up any kind of linear algorithm like this. So I feel like it has to be more natural, I guess. And in that case, I then need to kill them off by some kind of algorithm based upon life expectancy plus RNG. Population grows on a percentage based on their previous population size. Kind of. I'm trying to handle this currently using generations. So like the population consists of generations. So, and each generation is a slice of like 1 year. It could be a different amount of years, but right now it's 1 year. So every year, the idea right now is that I go through every generation that's above minimum birthing year or minimum birthing age, which is set to 18 right now, because that's politically correct, right? And don't want to set it to 16, but someone's gonna get mad. Anyway. And then I go through that, and then I create a new generation that's 1 year old or 0 years old, based on like the population in each generation times like their year or their age. You know, the older they are, the less they have children, right? So the generation is created that way. But then people have to die. And that's also like, both of these have to have algorithms that make sense. So for birthing right now, I'm using an in-out ease. I think this is a cubic in-out ease to handle the births. And I guess I could just use an ease out, right? Like, why am I looking at formulas again? I even have the ease. Right, like it could be just ease out like this. Ease out quint. Ease out quad. Ease out quart. There's like barely any difference. Ease out expo. This doesn't work either. Like, not really. It might be okay, kind of. But like, it's not actually correct, because an ease uses this formula or this format. But it might still be okay to do the same kind of method. And this is where it would be nice to have some kind of visualization, right? That's not something I felt like programming. I kind of wanted to just fuck around with just numbers and stuff. But like, it would be nice to have one of those population chart. You know, one of these. These. I think I should make, I should have something like this. It wouldn't be that hard to program something like that. I wonder, can you just draw? I think you can just draw. Like, you have draw here. Draw indexed primitives. Draw primitives. Monogame. Draw line. Line drawing. Get a 1 pixel texture. Yeah, I mean that is the easiest solution. Just make a make a little bar or something. I'm just gonna make it red for now, I guess. Hold on, I'm just making a thing. Monogame. Content. Alright, I don't remember how this works. Let's see. Let's boot up a new dinosaur. Content. Bin obj. Okay, so it goes in content, and then we're gonna say sprites. This is gonna be debug. I'm gonna call this population gauge. There should be data on average age a person has children. Maybe base your function on how that graph looks. Yeah, I think that's why that's why I kind of need to see like how each generation is actually changing over the year. Because like I said before, ideally the way it should work in a vacuum is that the population should grow, right? How much, I think, is a factor of fertility. Like fertility, I think, should be a value at least. So, oh man, what am I even talking about? I forgot what I was even saying. It's almost time to give up for tonight, by the way. My brain is cooked. Yeah, I need to see how the generations change from birth to death, right? Because no new people are ever going to be added to a generation unless there's migration. And that's, we're gonna deal with that later. But a population should always grow based on like the fertility of the species, because these might not be humans, so they might be whatever. Like it's just a basic concept. So within a vacuum, it might be like super exponential growth if they have like lots of children, like cats or something. But, and that's where like external factors come into play, like childbirth, death, first of all, and then also resources, events, you know, whatever, disease, that kind of stuff. And that should like tame the population growth. But generally speaking, even within that restriction, they should still grow, right? Unless they are, you know, in mortal danger and they're getting extinct. And then they're just fucked. So it's kind of hard to really figure out anything until we're at like a much more advanced stage. So I think if I can just figure out something here, like handle births. If that's okay, then that's okay. While here, this should be ease in out. No, this is death. Death should be ease in quint. So here we are entering a normalized value between 0 to 1, and then the easing will adjust the value to be more, you know, to fit into the curve. I have no idea how things are gonna go here. Not sure why people didn't die in the beginning. every 2 years right now, or every 2 seconds rather, a year passes. I think this actually looks kind of okay. Because the key aspect here is that we have population growth. It's uncontrolled, but that's okay. That's besides, you know, anything else. But the generation count is stable, and that's what's important. Because if the generation count goes up or down, that means that there's some kind of weird bias in the algorithm. Before, the generation count was going down to 10, like almost immediately, which means that no one is older than 10 years old, right? So at this point, this means that people live to 64 with the current algorithm. And the population is growing. There is no one older than 64, because if there was someone who was 65, then there would be a generation in the list. Or 65. Oh, someone survived. Oh. Generations are going up. We've come to a break point where it becomes bugged, I think. No, not necessarily. Not necessarily. It might be the case that there's such a small percentage of people that survive past 65 or 64 that they just get pruned out by the truncation when I cast it from float to int. So what's happening now is that because the population is so massive, those final decimals at the end towards 80 are able to be truncated without becoming 0. So it's not actually a bug, it's working as intended. But we have several millions of people now. Yeah, I think that's good. Well, now our population count is negative. Okay. Is that an overflow? How can it be an overflow? Like, that number isn't even high. Is that how high an integer goes? In integer 32-bit integer max value. Yeah, okay. Yeah, it is actually not larger than that. Alright, well that's fine. How large can a 64-bit integer be? That's really big. But I would say any population should not be... Actually, you know what? The population, it's a population count. Does monogame have int64 built in? Seems like it. Let's try that. It's gonna take a while to get there again, but... Because the way it works is that every single time that a population changes its internal count, it adds or detracts. I mean, generally speaking, it detracts, but like a generation might be born, and then that increases its population count. But every time the generation's population count changes, it adds or detracts the difference from the population it belongs to's population count. So therefore, the population's population count can just be an int 64, while the others are just int 32s, without it really mattering much. Because there are but way fewer populations, right? I think it started bugging out around year 200 or something. I just don't know. I just don't know if the setters are gonna do something weird, because like one is an integer 32 and one is an integer 64. Just not sure. But I think this is actually pretty good. Like, it's not perfect, but it's a start. And that means we can start throwing more things at it, like food, scarcity, you know, whatever. And we can have those type of things affect the values in some form or another. I also think the generations should be expanded on, because right now they're just having children, right? But I don't know if that's granular enough. It might be. But the reality is that I think my current algorithm basically forces like every single family to have like 14 children or something before they're done. And that's kind of weird too. So, but that's something that's a lot harder to keep track of, right? Or maybe not. I'm not sure. Like, so I need to keep track of how many had children last time. So maybe I just have like a list of births per generation, and then the next time that has to be incorporated. Because then it would be the first entry in the list could be, if we just say 0, right? Like, how many people have 0 children? No, that doesn't make sense. How many people have 1 child? That makes sense. And then you just store that. So if like 90% of the people in a generation have 1 child, you just add that value. Looks like we are having an integer overflow still. And if the 64, like this is the size of a 64-bit. If this was working correctly, that would not be overflowing right now, I think. So that's a lot of fucking decimals. But yeah, like, the first entry in the list is how many people have one child. The second is how many people have two children. Now, the first would overlap with the second, of course. So that's a little bit like... yeah, I don't know. But I feel like the more children they have, the lower should the chance that they... yeah, it should be more detailed. It should be like how many people only have one child, how many people only have two children, how many people only have three children. And the more children they have, the less likely it should be that they get more. I don't know if I'm overcomplicating it there, but I think that's fine. That's the kind of thing that I feel like could be just overlooked later, or like just like commented out more or less to save some processing time. Generation count is going down. Why is the generation going down? Just because I changed this to an int64. Besides, it should be a uint. So we can't have... in fact, this should all be uints. Because we can't have... negative population. And here, right, source population dot population count plus equals value, and I guess this is where the issue comes in, right? Because I can't make this calculation using uints. But this should also... I don't know where the issue comes in there. Whoa! Okay. Why? It just immediately went for the overflow. Oh well. I don't know. Not sure why that happened. Anyway, I think that's gonna be it. My brain. It's underflowing. Yeah. Oh yeah, YouTube delays like 40 seconds. Yeah. But we'll continue. I don't know if we'll do that tomorrow. We'll do it someday. We'll see. I'm just trying to get back to programming more on the side as well. Doing something that isn't necessarily just background, shader, rendering, pipeline, programming. Something that's just a little bit more functional. Just doing like simulations and stuff that then can be plugged into an engine. But yeah, I also want to do procedural generation, like world generations and stuff like that a bit. But I'm starting with the population first. I would like to try like tectonics and whatnot. Not really sure how to handle that though, but that stuff I would really like to mess around with. Anyway, thanks for hanging. Have a good